Here I have a problem from the LA City College 2008 math contest, and it tells us that 217 base x is equal to 574 base 9, and then asks us to find x. I really like these types of problems because they're good applications of exponents and logarithm rules that students might learn in a pre-calculus or math analysis type class. So let's jump into this problem. First, what we want to do is expand out this 574 base 10. And the way we do that is by multiplying each digit by what they represent. So this is the ones digit, so we're multiplying 4 times 9 to the 0, which is 1. And then we'll multiply 7 times 9 to the first, that's because that's the nines digit. And then 5 by 9 squared, or 81, because that's the 81s digit. It's 9 to the second. But now, adding all of these together, we get 4 plus 63 plus 405, which gives us 67 plus 405, which is 472. And I'll go ahead and make a note that this is base 10. So now what we want to do is expand this 217 base x out to base 10 and then compare the two numbers. So let's go ahead and do that. First we'll have 7 times x to the 0, that's the ones digit. And then 1x to the 1, that's the x digit. And then 2x squared, that's the x squared digit. But now adding all that up, we get 7 plus x plus 2x squared, and this is base 10. But now we can set these equal to each other because we know that these two expressions are equal. So we have 2x squared plus x plus 7 equals 472. And this is all base 10 now. But now we can subtract 472 from both sides of the equation and we're left with a simple quadratic. So we have 2x squared plus x minus 465 equals 0. But now what we can do is take this quadratic equation and use the quadratic formula to solve. So we'll have x equals -1 plus minus the square root of 1 squared minus 4ac, but that's 4 times 2 times -465. So we'll go ahead and add these and multiply by 8 and then 465. And then divide by 2a, but a here is 2, so this is all divided by 4. But now adding 1, that's 1 squared, to 8 times 465 gives us exactly the perfect square 61. So we have -1 plus minus 61 over 4. And we're only looking for positive solutions here because we're assuming that we're only looking for a positive base here. So we'll take positive 61, but that gives us 60 over 4, which is 15. And that tells us that this number 217 is in base 15. So the other solution to this quadratic here gives us -15.5. But like I said, negative bases don't make a lot of sense for a number of reasons, but mainly because when we take an even power of a negative number, we get a positive number, and those would conflict a little bit. And that's enough for now.